Now let's find the equivalent resistance between A and B using star delta transformations. Though it can be solved using the method of symmetry also, but right now we are more interested in applying star delta conversions. So here we see that this is a small triangle with each side resistance equal to R, and over here there is a bigger triangle, once again with each side equal to R, and all the vertices, they are joined to the vertices of the triangle by a resistance R, We have to find what is the equivalent resistance between A and B. So we see over here that is one delta we see over here. Though this is also bigger, is also a delta. Let's start with smaller delta. We can convert this delta configuration into star configuration. So resistances, they will be replaced by like this. This is once again is going to be, this resistance is going to be multiply both the sides, that is R into R, R square, divide by the sum R plus R plus R, that is 3R. So this is going to be R by 3. All the resistance, they are equal to R only. So this is going to be R by 3. Similarly, this is going to be R by 3 and this is also going to be R by 3. Once we have done the delta to star transformations, this delta goes off. This delta goes off, and we know that is all these resistances, they are R by 3 only. Now we see that is this R and this R by 3, they are in series. That is one after the other, they are connected end to end. So R plus R by 3 is equal to 4R by 3 is the resistance of these two in series. So we can replace by a single resistor, that is 4R by 3. Similarly, this and this, they also make 4R by 3, and this, they also make 4R by 3. Now we have one delta is there and one star is there. What we can do is, we can convert this delta into star. One star already we have. This outer delta we can convert to the star, and we can get the answer, that is equal resistance between A and B. And we can also convert this star into delta, and we can find once again the equivalent resistance between A and B. Obviously, both the answers, they will match. Let's convert this star into delta. We know if this is A, B and C, this is R1, this is R2, this is R3, that is delta, and we have a star over here. When we are going to replace by a star, that is R4, R5, R6. This is star, this is delta, and when we go from star to delta transformation, that is star values, they are known, and delta values, they are found out. So the value of R1 we have found. How we have found out? That is R4 into R6 plus R6 into R5 plus R5 into R4, this into this plus this into this plus this into this, divide by opposite to R1 is R6. This is how we understand the star delta transformation values. Similarly, over here, if we have, this is 4R by 3, we say, this is 4R by 3, this is 4R by 3, this is 4R by 3. Let's we call it as this is A, this is B, and this junction, let's we call it as X. So between A, B and X, so this is X, this is A, and this is B. Now what we intend to do is, we are not disturbing this delta, but we are converting this star into delta. So here we have this star, and we wish to find out what are the values of this delta if we wish to create delta. Over here we see all the resistance values in the star configuration, they are same. So obviously, what's the value of this delta configuration comes, the same value be of this, the same value be of this. Let's find one value. So the value of this, let's say if we find the value of this one side is going to be 4 by 3R, this into this plus this into this, 4 by 3R into 4 by 3R plus this into this, right? This into this plus this into this plus this into this, that is what we have done. This into this plus this into this plus this into this. Then in the denominator opposite to this one. In the denominator opposite to this one, that is 4 by 3r. Or it comes out to be 4r. So it means each side it comes out to be 4r, 4r, 4r. So if we are interested in replacing this star into delta, what we have to do is we remove this. So we remove this star and we replace it by a delta. Delta is shown in red color ink. So this is 4r, this is 4r, this is 4r. See, we have not disturbed the junctions. These three junctions, they have not been disturbed. The resistances, they are still, all the resistances, they are still connected at X, A and B. So now what we do is we have to find the equivalent resistance between A and B. So that there is no confusion. Now its job is done, but it is still connected over here. Let's find the equivalent resistance between A and B. So what we see over here is from here to here, this and this resistance, they are in parallel. That is, both of them, they are splitting over here, and they are both of them, they are reuniting over here. So this and this in parallel. So we can easily find the equivalent resistance of this and this. So if it is R dash, so equivalent resistance R dash is 1 by R dash is equal to 1 by R plus 1 by 4R. So we find the value of R dash, and now we can replace this by a single resistance, that is R dash, right? Similarly, between this and this, once again there R and 4R, they are parallel. So we can replace by a single resistance R dash over here, whose value is calculated from here. Similarly over here, 4 and R, between this and this resistance and this resistance, they are in parallel. We can find our equivalent resistance. R dash is going to be same, that is R dash only, because both the values, they are same. So this is R dash. Between A and B, we see that this and this, they are in series. R dash and R dash, they are in series. So we can replace it by a single resistance R dash plus R dash, that is 2R dash, where the value of R dash is given by this. Now between A and B, R dash and 2R dash, they are parallel, and we can find the equivalent resistance, that is R double dash is equal to 1 by R dash plus 1 by 2R dash. So this way we can find the value of R double dash, that is the equivalent resistance between A and B using star delta transformations.